Welcome back, Logan, to another installment of Math from Your Couch. So today we're going to move on to a new topic, but before we do that, I just kind of want to quickly review what we talked about in the last video. And what we were doing is we were taking a look at circles and their circumferences. So this circle right here is what we would call circle E. Now the question is what is the circumference of this circle E given that it has a radius of 6? Notice that the radius of 6 is, the reason we call it the radius is because it starts at the center of a circle and extends to the edge of the circle. Now, to do this, we actually need to use the formula that the circumference is equal to the diameter times pi. This sucks. And the reason it sucks is because it says diameter times pi and not radius times pi. So we need to do just a slight amount of thinking here. So given that the radius is 6, well, what's the diameter? Now, some of you are like, well, if you extend the radius, you'll get a diameter. Exactly. So if we extend this radius right here, what we end up getting is the entire diameter. Now, if this radius is 6, then that means this radius here must also be 6. So adding the two radii together, we get the entire diameter to be a total of 12. So we now know that the diameter is 12. So we can say the circumference is equal to 12 times 3.14. You'll notice that from here on out, I'll be approximating pi to 3.14. And now we just need to simplify. We need to take out a calculator. So I'll bust out my Desmos. If you don't know where Desmos is, go to desmos.com and just say start graphing. Now I know it sounds kind of weird to say start graphing because you're not going to be graphing it, but that's the cool thing about Desmos is you can just type in what you want it to do. So I want it to multiply 12 times, shift 8 is times because it's that little star key, 12 times 3.14. And what we come up with is 37.68, 37.68. So we're going to write that down. Our circumference of this circle is 37.68. And that is what we talked about in the last video. So the next topic is to take this idea and extend it just a bit. What if I asked not for the entire length around the circle, but what if I asked for just that piece of the circle? I only want to figure out what that piece is. This is what we call arc length. Now, arc length is just a portion of the circle's circumference. So we only want part of the circle's circumference. The way that we're going to achieve this is we're going to start by drawing two radii. Our first radius has already been drawn. Now the two radii that I need you to draw start from the center and extend to the ends of our arc. So we're going to have a radius that's drawn from E to B, our first ending of our arc, and then E to A, the other ending of the arc. Now when you do this, you'll notice that these two radii meet in the center and create this thing that we call a central angle. Makes sense. It's in the center and it's an angle. So we get this central angle right here. So we're going to say that this central angle is 100 degrees. Why? Because I'm just making up a random problem. So this right here is a typical problem of finding the length of the arc. Now, rather than just telling you the formula, what I want to do is kind of deconstruct the formula. Like, how does this formula come to be? So here's my plan. What I'd like to do is I'd like to set up a ratio of the part of the circle that I have over the entire circle. Okay, one more time. The ratio I'm going to create is part of the circle over the entire circle. So this right here is the part that I want. And what we're going to call this is the length of the arc. So I'm going to say that the length of the arc is part of the circle, and then the entire circle is 37.68. And this gives us this fraction. The length of our circle AB, the length of the arc AB, the length of the arc AB divided by the entire circle's circumference. Now, this is going to be the ratio's key. Everything on the top will always be the part of the circle, and everything on the bottom will be the entire circle's measurement. I now need a second fraction. So my second fraction is going to have to do not with the length around the circle, but actually the angle associated with those lengths. Now you'll notice that the angle that is associated with this arc is the central angle of 100 degrees. Now some of you can recall or even know from either skateboarding or basketball or anything that has to do with rotations is that a full rotation around the circle is often equated or the same as 360 degrees. And this gives us our second fraction. So what we have is a new ratio. So we have two ratios that should equal each other because they are proportional. The first ratio is that the length of the arc divided by the entire circumference of the circle is our first ratio. It must equal our second ratio. Not the length of the arc, but now it's going to be the angle associated with the length of that arc, the angle associated with that arc, or the corresponding angle to that arc, is going to be 100 over the entire circle's rotation, the entire circle's angle, which is 360 degrees. So now I have this equation set up. So if I wanted to figure out how big this was, all I need to do is solve this equation. And we start by cross multiplying. So we're going to cross multiply. That means the 360 is going to get multiplied to the length of the arc. So the 360 is going to get multiplied by the length of the arc. Yeah, I got lazy. I just wrote the L for the length of the arc. So we have L times 360, and then we're going to have the entire circumference multiplied by the 100. All right, I'm lazy once again, so I'm not going to actually multiply what's in blue over here. I'm just going to get the L by itself. So to get the L by itself, I'm going to divide both sides of our equation by 360. Now dividing both sides by 360 results in the L, the length of the arc, being by itself. So all I need to do now is pull up my Desmos and multiply the 100 by 37.68 and then divide it by the 360. So I throw open Desmos. I need a new dialog box. So I'm going to have a fraction. On the top of my fraction, we had 100 times 37.68. So I'm going to type out 37.68. I now need to get to the bottom of the fraction, so I'm just going to type the arrow key downward. And this gives us the denominator, which is going to be 360. And you'll notice that we come up with 10.4666667. We only went around to the second decimal place value, which means we're going to look at the 6, the second position, and then we're going to look right after the second position at the third position. And you'll notice that in the third position, there's a number bigger than 4, not bigger than 4, that is 5 or bigger, right? So it's bigger than 5. So if the number's bigger than 5, then we're going to round up. If it's 5, then we're going to round up. If that number was less than 5, we would keep it exactly as it is. So we're going to go 10.47. So we're going to type in, or we're going to write out that our arc length, so the length of arc AB is in fact 10.47. So now we know what the length is right here. It's 10.47. All right, so what I'd like to do is I'd like to take a look at the formula. This is the thing you're going to want to write down. So you're going to want to write down at the very least this piece. So our formula that we're going to be working with starts off like this, the length of the arc. Now remember, we're going to have two fractions for this formula. Now the first part of our fraction is going to have the length of the arc over the circumference of that, sorry, I need to go back a second, the length of the arc over the circumference of that circle. So we're going to say the length of the arc divided by the circumference is equal to, that's our first fraction. Our second fraction is going to be the angles. So the angles, I'm going to say, is the measurement of the angle associated with the arc, the measurement of the angle associated with the arc. So some people call that the measurement of the arc, divided by, now remember, this thing right here is an angle. So in parentheses, if you want to write angle, you can, divided by the entire circle's angle of rotation, which is 360 degrees. And this right here is our formula. So what I'd like you to notice is that on the top of both of my fractions are just the parts of the circle, and on the bottom of both of my fractions are the entireties of the circle. One more time. The bottoms are the entirety of the circle, the full circle, and the tops happen to be just the parts of the circle.